Hello everyone. In this video, we are going to see the subject named Control Systems. This is Divya, working as Assistant Professor in R.M.K. College of Engineering and Technology. The topic what we are going to see now is block diagram and its rules. First, let me tell you what is meant by block diagram. It is the pictorial representation of a functions performed by each component and of the flow of the signals. It also depicts the interrelationship that exists among various components. Many components will be combined together to perform a specific task. Each and every component will be having its own function, and we have relationship between those blocks that will be depicted by the concept called block diagram. Then we are going to see now the rules for block diagram reduction. Rule number 1, combining the blocks in cascade. Rule number 2, combining the blocks in parallel. Rule number 3, moving the branch point ahead the block. Rule number 4, moving the branch point before the block. Rule number 5, moving the summing point ahead the block. Rule number 6, moving the summing point before the block. Rule number 7, interchanging the summing points. Rule number 8, splitting the summing point. Rule number 9, combining the summing point. The next two rules are most important rules we will be using in many block diagram reduction methods. Rule number 10, elimination of positive feedback. Rule number 11, elimination of negative feedback. Now let's see every rule in detail. Rule 1, combining the blocks in cascade. So let me assume like I have a block whose gain is G1. I am going to give an input named X. So output coming from this block will be G1 into X, that is input multiplied by the block gain will be the output. Now this will be fed as input to another block whose gain is G2. So the output will be Y, whose value will be equal to G1 into G2 into X. Now we can see here we have two blocks in cascade combination. Now my input should be X, the output what I need is Y is equal to G1 into G2 to X. So now I have to insert only one block in between these input and output. The value of that block should be, of course, it should be G1 into G2. Product of two gains. Suppose I have three blocks in cascade, G1, G2 and G3. Then my output will be Y is equal to G1, G2, G3 into X. Now in this case, my output is not G1, G2, X. It is G1, G2, G3 into X. So my block should be G1, G2, G3. So the inference from this rule 1 is when the blocks are in cascade, we have to multiply the gains. Rule number 2, combining the blocks in parallel combination. Let me assume like we have two blocks G1, G2 in parallel combination. I have an input called A given in parallel to both the blocks. My output of the first block will be AG1. Output of second block will be AG2. Now I am going to add these two things. So final output will be AG1 plus AG2. Otherwise we can also write like A into G1 plus G2. Now same thing, I am going to give a same input called A. Now the output what we need is A into G1 plus G2. So the block that we have to insert here is what? G1 plus G2. Now let us assume like I have three blocks in parallel, G1, G2, G3. In that case, my output will be AG1 plus AG2 plus AG3, that is A into G1 plus G2 plus G3. So in this case, my output should be A into G1 plus G2 plus G3, means the block value that we have to add here is G1 plus G2 plus G3. Inference what we get from this rule number 2 is when the blocks are in parallel, we have to add the gains. Rule number 3, moving the branch point ahead the block. I have a block called G1 whose input is A. I have a branch point. So the gain what we achieve in this branch point is also A. Now we have output whose value should be A into G1. Now the same branch point should be moved ahead of this block called G1. So input is A, output is AG1. Now the branch point should be moved ahead of the block called G1. So what we achieve here is only AG1, but what we require here is only A. So when we want a gain named A, we have to insert a block whose value is equal to 1 by G1. so that I'll be getting the preferred value called A. So the inference what we get from this rule 3 is when a branch point is moved ahead a block called G, insert a block value 1 by G in the moved branch. We have to add that block with the value called 1 by G in the branch that is moved from one point to another point. Rule number 4, moving the branch point before the block, just opposite to rule number 3. We have a block called G whose input is A and we have a branch point here. The outputs what we have here is AG1. Now the same block called G1 we have the same input called A. We have the output called AG1. Now this branch point should be moved before the block. So when we move before the block, what we have here is only A, but what the branch point earlier has is A into G1. So now when we want to achieve the same output, we should add a block whose value is equal to G1. So the inference what we get from this rule 4 is when a branch point is moved before a block called G, insert a block G in the moved branch. Rule number 5, moving the summing point ahead a block. Now we have a block called G1. We have a summing point where we are going to add 2 or more signals. We have 2 signals called A and B. Let us add these 2. So the input given to the block G1 is A plus B. Output what we have is A plus B into G1. Same thing, now we are going to move the summing point ahead the block. We have a block called G1 whose input is A, and the output side we have a summing point. We are going to add the signal called B. So what we need here is A plus B into G1. So we don't have BG1. So what we have to do, we want BG1 means I should include a block named G1. So the inference from this rule 5 is when a summing point is moved ahead a block G, insert a block G in the moved branch. Rule number 6, moving the summing point before the block, just opposite to rule number 5. We have a block called G1 whose input is A, output is AG1. We have a summing point. We have an input called B to the summing point. When we add these 2 signals, we will be getting AG1 plus B. Now for the same case, we have a G1, the summing point is moved before the block. So the input given to the summing point, one is A, other one is B. Now what we need here is AG1 plus B. Now what we have here is A plus B by G1. That is what we need here. Then only we will be having the output as AG1 plus B. So A is given here. We want B by G1 on the second branch. So we want B by G1 means I should add a block named 1 by G1 over here. So when a summing point is moved before a block G, insert a block whose value is equal to 1 by G in the moved branch. Rule number 7, interchanging the summing points. When we have 2 summing points for which we have inputs called A, B, output of first summing point will be A plus B. Second summing point, we have another input called C. The output will be A plus B minus C. Now we can interchange this first and second summing points in the same manner. We will be having the same output. For first summing point, A and C is the inputs. So second summing point, the input what we have here is B. So now we have A minus C as one input and B as the another input. So totally we have A minus C plus B. Rule number 8, splitting the summing point. So now we are going to reduce one summing point into 2 summing points. We are going to split the summing point. Now we can see here we have a summing point for which we have 3 inputs A, B and C. So now output will be A plus B minus C. Now this summing point can be splitted into 2 summing points. Each and every summing point can be provided with 2 inputs. First one, you can have A as the input and B as the input. The output what we have here is A plus B. For the second summing point, we can have the C as the input. So ultimately what we will be having is A plus B minus C. So now we have divided one summing point into 2 summing points. Rule number 9, combining the summing point, just opposite of rule number 8. Now we can see here we have 2 summing points, one A, B. So the output will be A plus B. Another input is C. We have here A plus B minus C. Now instead of these two summing points, we can have a single summing point for 3 inputs A, B and C. So finally my output will be A plus B minus C. Rule number 10, the most important rule, elimination of negative feedback. So here we have blocks. We have a summing point for which we are going to have a negative feedback. Your feedback fraction is H. Input what we give is R. Output what we get is C. So now we are going to replace these two blocks and your summing point with a single block whose input is R and whose output is C. So value of the block that we are going to add is G by 1 plus G into H. This is the most important rule that we'll be using. Rule number 11, another important rule, elimination of positive feedback. For same case, we have a block called G, we have a summing point for which we are going to give a positive feedback. Feedback value is H. So input is R, output is C. Now for the same input R, same output C, we should have a single block in between this input and output whose value should be G by 1 minus GH. So now we have seen all the rules for block diagram reduction method. Next video, we'll see some problems in block diagram reduction. Thank you all.